Welcome to qnawire.
So let's find the Laplace transform of this function. So I can write this as t square into, use cos of a plus b formula. It is cos a cos b, that is cos 30 plus minus sine a sine 30, that is half, into u of t. So basically it will be root 3 by 2 into t square cos 2t u of t minus half t square sine 2t u of t. Now remember, there's a formula, Laplace transform of t power n f of t is negative 1 power n into the nth derivative of f of s divided by ds power n, where f of s is basically the Laplace transform of f of t. So first, what is the Laplace transform of cos 2t u of t? It is s by s square plus 4. Now you are multiplying with t square, so it will be root 3 by 2 into the double derivative d square by ds square by s square plus 4 minus half into, similarly, d square by ds square by, what will be the Laplace transform of sine 2t u of t? It is 2 by s square plus 4. So basically we need to double differentiate now. So it is root 3 by 2 into, so I'll put a bracket for the double differentiation minus half of, I'll put a bracket for this for the double differentiation. So let's do the double differentiation. S by s square plus 4, double differentiation. First derivative is s square plus 4 whole square, s square plus 4 into derivative of s, which is 1, minus s into derivative of s square, which is 2s. So basically it is 4 minus s square by s square plus 4 the whole square. Let's differentiate one more time. So it will be s square plus 4 whole power 4, s square plus 4 whole square into negative 2s minus of 4 minus s square into 2 into s square plus 4 into 2s. S square plus 4 you can take common, so minus 2s into s square plus 4 minus 4s into 4 minus s square divided by s square plus 4 the whole cube. So if you simplify numerator, you get 4s cube minus 2s cube, that is 2s cube, minus 8s minus 16s minus 24s divided by s square plus 4 whole cube. And how about this thing? So this double derivative, let's calculate. What is the single derivative of it? The single derivative, it is minus 2 by s square plus 4 whole square into 2s. So basically the single derivative is minus 4s by s square plus 4 whole square. Let's differentiate again. So it will be s square plus 4 whole to the power of 4, s square plus 4 whole square into derivative of s, which is 1, minus s into s square plus 4 whole square derivative is 2 into s square plus 4 into 2s. So let's simplify it. So s square plus 4, again you can cancel out in the denominator, so you'll get s square plus 4 whole cube, and numerator will have s square plus 4 minus 4 s square. So basically it is 4 minus 3s square, minus 4 into 4 minus 3s square, that is 12s square minus 16. So 12s square minus 16 divided by s square plus 4 the whole cube. So now let's write the final answer. So because here 2 gets cancelled, so 2 here 2 gets cancelled in 12 times. So root 3 times s cube minus 12s. So root 3 times s cube minus 12s. And how about the other one? Here 6x square minus 8 minus of 6s square minus 8 divided by s square plus 4 whole cube. So this is the final answer for the first question. The next problem is 3t power 4 e power minus 2t u of t. What is the Laplace transform of this? It is 1 by s plus 2. The Laplace transform of this is 1 by s plus 2. 3 let's multiply later. Now you are multiplying with t power 4. That means the final answer for the Laplace transform of this is minus 1 power 4 into 4th derivative 3 power 4 by ds power 4 by 1 by s plus 2. So let's quickly calculate the 4th derivative. It's very easy. What is the first derivative? It is minus 1 by s plus 2 whole square. What is the second derivative? It is 2 by s plus 2 whole cube. What is the third derivative? It is minus 6 by s plus 2 whole to the power of 4. What is the fourth derivative? It is 24 by s plus 2 whole to the power of 5. Now multiply finally with 3. So the answer is 72 divided by s plus 2 whole to the power of 5. So this is the answer for this question. What is the Laplace transform of u of t? It is 1 by s. So what will be the Laplace transform of t times of that? It is 2 times the derivative of 1 by s. It is minus 1 by s square minus 4 into what is the Laplace transform of derivative of a function? The Laplace transform of derivative f dash of t is s into the Laplace transform of f of t minus f at 0 minus. But delta of 0 minus is 0. So it's basically s into Laplace transform of delta of t, which is 1. So it is s. So the answer for this question is minus 2 by s square minus 4s. This I can write it as 2e into e power minus t u of t. What is the Laplace transform of this? It is 1 by s plus 1. So the answer is 2e by s plus 1 because e is a constant. Laplace transform of f of at, if a is a positive number, is 1 by a into f of s by a. So what will be the Laplace transform of u of t by 2? Basically, what is Laplace transform of u of t? It is 1 by s. So what will be Laplace transform of half t? It will be 1 by half into 1 by, replace s with s by half. So basically it will be half gets cancelled. So again it will be 1 by s. So the answer will be 5 by s. So this is the answer. 6 e power minus t by 3 u of t. This is the next question. So it is 6 e power minus t by 3 u of t. How to find the Laplace transform of this function? So let's do it. Laplace transform of f of t is f of s. What is Laplace transform of e power minus at f of t? It will be f of s plus a, because let's derive it. It will be integration from minus infinity to infinity, e power minus at f of t into e power minus st, which is nothing but minus infinity to infinity f of t e power minus of s plus at dt. This is nothing but f of s plus a, because f of s is integration from minus infinity to infinity f of t e power minus st. So what is a here? 1 by 3. So first of all, what is Laplace transform of u of t? It is 1 by s. So what will be the Laplace transform of e power minus a, which is 1 by 3 t into u of t? It will be 1 by s plus 1 by 3. But 6 is there multiplied. So final answer is 6 times 1 by s plus 1 by 3. I can write it as 3s plus 1 by 3. So answer is 18 by 3s plus 1. So this is the answer for this question. As far as nth derivative of Dirac delta function is concerned, the Laplace transform actually does not exist, because the function, this Dirac delta is not differentiable at 0. So that means the derivatives at 0 does not exist. So there is no question of finding the Laplace transform. So basically the Laplace transform does not exist.